Here is an example. In this example, he's asking us to design an operational amplifier which will give us this output. The output must be like 2VA minus 3VB plus 4VC minus VD plus 7VA. Here I have how many inputs? These are all inputs, A, B, C, D, E. All these are inputs. I have 5 inputs. Okay, so one output. Now, I'm going to use 2 operational amplifiers connected in cascade or in series, back to in series connection. And it's going to be inverting amplifier. I'm going to use inverting amplifier. So first thing, what I'm going to do, whichever values have positive numbers, okay, those are going to be inputs of the first operational amplifier. Okay, so the first operational amplifier is going to be something like this. All we know, there won't be any current going in here. Okay, current going in here is 0 ampere, current is here is 0 ampere. That's one of the important point. Another one is this is V2 and this is V1. We know that always V1 equal to V2. Now, how many positives I have? 1, 2, 3. So 3 positives. All the 3 inputs are going to be connected here. Okay, so this is VA, VC, and VE. Now, how many negatives are there? I have 2 negatives. So the next one is going to be, I'm going to connect 2 negative inputs. So the negative input is VB and VD. Okay, so here is my second one. So any questions so far? Okay, now this is the feedback resistor, RF. Always choose the feedback resistance first. That makes it your life easier. I'm going to choose this RF as, it doesn't matter, like 50K, 40K, 100K, 60K, but I usually go with whatever the common factor here. I don't see any common factor because of the 7 VE, but I think 60 works for everything, so I'm going to take this as 60K. Okay, now to get the output here, let me take this as Vx. Okay, my Vx equal to RA, RB, RC. You can apply KCL here, or the simple way I usually recommend you to remember, this is RF over RA times VA plus RF over RB times VC or VB. Oh, in this case, VC. Let me take this as RC to avoid confusion. I'm going to take this as RE. So this is RC. RC times VC plus RF over RE times VA. That's my Vx. Okay. Now, what is the coefficient of VA? Is 2. The coefficient of VA here is 2. So I need to have the 2 here. I mean, RF over RA must be 2. So which resistor should I choose to get 2 value there? I already chose RF as 60K ohm. So RA must be 30K, right? So that way I will end up having 2 VA. Okay. And VC must be 4. So 60 divided by some value must be equal to 4. So can I take this as 15K? Okay, then I'll end up with this value as 4. And here RF over RE, I mean, there is no common factor, but I'm going to take this as 60K divided by 7. That will give me 7 here. The coefficient of VA will be 7. Any questions how I chose RA, RC, RE? Okay. I mean, I directly wrote the equation here, but you can get this equation by applying KCL at this node. It's the same thing. Okay. So once I have that, here I have Vx. All I need to do is, this is inverting amplifier. So all I need to do is get the positive numbers of those three. So whatever the resistance value I'm choosing here, let me choose 60K. I have to choose the 60K because it doesn't need to amplify. All it needs to be inverted. Okay. So VB, I'm going to choose this as RB, this as RD. So the coefficient of VD is 0. Sorry, coefficient of VD is 1. So I'm going to choose this as also 60K, and VB has 3. So 60 divided by 20K will give me 3. This is the final circuit, but we'll verify what will be our V0. Okay. Our V0 is going to be, you can do apply KCL here, or the equation is going to be similar to this. So V0 is equal to, can I say it's negative of 60K divided by 60K times Vx plus 60K divided by 20K times VB plus 60K divided by 60K times VD. Okay, so this Vx, so 60K divided by 60K, which is 1, but I already know Vx. Vx has a negative value, so I'm going to substitute a positive value, negative of negative, which is going to be positive. So 60 RF is 60 divided by RA is 30, and that value is 2 VA plus RF over RC. RF is 60K, RC is 15K, which is 4 VC plus 60K divided by 60K divided by 7, which is 7 VC. Okay, and then here I'm going to take this negative inside. That's going to be negative 60 divided by 20, which is 3 VB minus VD. Okay, that's the output, and that's what the given question is. Okay, so this is our final design. Some people might say, can I take the negative inputs and say, here is my inverting amplifier, but here I'm going to take all those inputs right here. I think we have 6 inputs, right? 1, 2, 3, 4, 5 inputs. Okay, assume that I have something like this. Now, can I write this as a negative value? So I'm going to take this as negative. At the end, I'll end up with a positive number. VA, VB, negative VC, VD, negative VE. Okay, whichever has a positive value here, those are all I chose them as negative, because if I chose the negative value here, it's an inverting amplifier, so it will invert and give you the positive value. This is another way to do it, but probably I prefer you to draw this one compared to this one, because it's only, I mean, because I would say there are no negative voltages available with us. Okay, that's the reason I don't want you to design this. I want you to design this.